Now, after discussing the manometry, we will discuss the Bourdon type pressure gauge. In this Bourdon type pressure gauge device, we have a pressure sensor here. This fluid will enter through this hollow tube, and this hollow tube is connected to this another hollow tube up to this point. Now, the cross section of this tube is elliptical. It is shown here. Cross section of this tube is shown here. This is elliptical in shape. Now, one end of the tube is connected to this rack and pinion arrangement. This is connected to this lever. This is connected to another lever. Then here we have a geared arrangement, rack and pinion arrangement. So, as this moves, takes the curve, this indicator is fitted on this pinion. As this pinion moves, this indicator moves on this scale, and if we can relate the movement of this Bourdon tube to this pressure gauge, then we can find out the pressure which is fed here. Now, whenever this pressure is fed, then this pressure tries to flatten this Bourdon tube. It tries to flatten it, means it tries to move this end in this direction. So, movement of this Bourdon tube is function of the pressure. Now, this movement is related to pressure, and this movement is connected to this rack and pinion arrangement. So, this indicator can be calibrated in terms of the movement of this Bourdon tube, which is function of the pressure. If more pressure, there will be more movement. If less pressure, there will be less movement. So, in this manner we can calibrate it, and this is very old device, still being used in different industrial applications, right. So, this is Bourdon tube pressure gauge device. Now, we have these two figures in which we have modern pressure gauge devices, where what we are doing, we are converting the pressure into some kind of electrical arrangement, voltage say, and this when we convert the pressure with the help of some suitable mechanical arrangement into electrical signal, voltage, current, etc., then it is very easy to manipulate this signal with the help of latest electronic equipments, amplifier, etc., can be transmitted, can be directly fed into computer, where computer will take the necessary decision also depending on the algorithm fed into that computer. So, in this manner, this once we convert the pressure signal into some kind of electrical signal, then electrical signal can be directly fed into computer, and this computer will automatically take care of the process which is being controlled, being pressure as one variable. So, here in this figure we have a Bourdon gauge. Now, this Bourdon gauge movement is function of the pressure. So, because of this movement of this Bourdon tube, this core is moved, and because of that we have a LVDT, linear voltage differential transducer. So, different type of flux is cut here, because of that a voltage is created, right. So, this voltage creation is function of the movement of this rod. Similarly, we may have diaphragm type pressure measuring devices, where we have a diaphragm. With the help of this diaphragm, look at this figure, with the help of diaphragm, if pressure is more, then diaphragm movement will be more, and with the help of that we can convert this movement of the diaphragm into some kind of electrical arrangement, electrical signal, and this electrical signal will be manipulated later on.